Now, let's say you have an individual that is exhibiting a dominant trait, but you don't know if they're homozygous dominant or heterozygous, because you can't tell just by looking at somebody with the dominant trait if they are. So what you can do is what is known as a test cross. And a test cross is used to determine if an individual with the dominant phenotype is homozygous dominant or are they heterozygous. All right? So what you do is you cross that individual with that dominant phenotype with an individual that is homozygous recessive. So here we don't know if they're big P or big P, little p, and we're going to cross that with an individual that is little p. Okay? So, two possible outcomes here, right? If they are homozygous dominant, what we should see is all the offspring show that dominant trait. If they are heterozygous, right, what we should see here is a 1-to-1 ratio or 50-50. All right? Now, here's the thing, right? What if you did this and you got 12 offspring and, instead of being 66, maybe it was 7-to-5. Which of these two would it be? Well, it would be this one because you got some recessive traits showing up. What if it was 9-to-3? Which of these two would it be? Well, once again, it would be over here because, right, you still have that recessive trait showing up. Even if it's 11-to-1, still over here because that recessive trait is showing up in the offspring. So you can think about this like just flipping a coin, right? If we got 12 offspring and we flipped a coin 12 times, we could get 12 heads or 12 tails, right? Now it's unlikely, but it could happen, right? So even so, right? So this will move for me and it's not. So if we see any recessive traits show up there, it has to be heterozygous, not homozygous dominant. All right, so now let's look at tracking traits. So tracking traits is used in what is known as a pedigree. So a pedigree is a chart that shows the pattern of inheritance for a particular trait. And on this, we see males represented as squares and females as circles. All right? And oftentimes, the shaded there is those that are affected. And why we say affected is because most of the times when we do a pedigree, we're not doing it for a trait like what we see here, which is a widow's peak. All right? Now, there are three types of pedigrees to look at. One type is called an autosomal recessive. So if we go to this next one here, so an autosomal recessive trait, so an autosome, if you guys remember, are the non-sex chromosomes. All right? So with an autosomal trait, we're going to see it in both males and females. And if it's recessive, what we should see with recessive traits is recessive traits will skip a generation. So this individual has it here. We don't see his daughter having it, but his granddaughter has it here. Here, we don't see it here at all. We don't see it in that individual, but it shows up here. And that is indicative of a recessive trait. All right? So, recessive traits can skip generations, and they can also have carriers. And a carrier, what we see here, are individuals that do not possess the trait, but they can pass it on to their offspring. All right? These two individuals are also carriers. These offspring of theirs have it. All right? Next is autosomal dominant. And an autosomal dominant, once again, autosomal. So in both males and females. With autosomal dominant, though, all you need is one allele for that trait. So there are no carriers here. All right? And it does not skip generations. And so that's what you can see here to here to here. That trait, a widow's peak, does not skip those generations. All right? So the next one, and I don't have a complete pedigree of this, is a sex-linked trait. Now, sex-linked traits, these are on the sex chromosomes. All right? And for reasons we'll talk about later, these are much more common in males than they are in females. Doesn't say females can't be it, but most of the time what we see with these traits is they're primarily males. All right? So this is showing a pedigree, and just a partial pedigree, of Queen Victoria. Now, she was a carrier for hemophilia. Now, hemophilia is a trait in which you don't produce a clotting factor. And so because you don't produce a clotting factor, you bleed very easily. So Queen Victoria, she was a queen of England back in the 1800s, and a lot of her descendants either were carriers for hemophilia, that's what this half shaded is trying to show, or they had hemophilia. Okay? So what we see with that was that the males will have this. So this is Alexis right here. He had hemophilia, so he didn't have this clotting factor. All right? And so what also we see with these sex-linked traits is that females will be carriers for it more often, and they'll not have that trait, but they can pass it on to their male offspring. And a lot of times, not all the time, but a lot of times we see a specific pattern in it skipping generations, in that a maternal grandfather will have it, and then the grandson will have it. That wasn't the case for Alexis, but it happens quite a bit.